This is the ERLC Show, a production of the Edmonton Regional Learning Consortium. I am your host, Shane Lawrence. And coming up on December 9th, we've got David Martin, who will be giving a session on engaging math learners with technology, Equatio, Desmos, Geogebra, and more. And I sure hope I said that right. And then on January 27th, Dave will be back with differentiating math assessment in the grade 7 to 12 math classroom. Both those sessions are at the ERLC office, and you can register today at www.erlc.ca. And now here to tell us a bit more about both those sessions is the man himself, Dave Martin.
Yeah, no worries. I'm out of Red Deer. I'm a high school teacher by trade and now central office staff. So
Okay. So what are you doing in central office?
I have the best job on the planet. I get to go from pre-K classes to AP calculus classes talking about mathematics.
Wow, that's awesome.
Yeah.
Okay.
I can literally get paid to talk about prime numbers every day. It's awesome.
That sounds tremendously nerdy. I like it. Awesome. Okay. So Dave, you are going to be doing a session on December 9th. And I think also on January as well, right? Oh gosh, I've lost my notes.
Yes.
January 27th as well, at the ERLC office. So maybe just before we dive into the nuts and bolts of all that stuff, can you just give me a quick overview, like who you are and what you do in the education world?
Yeah, sure. So my name's Dave Martin. I guess the academic part of me, I have a master's in mathematics education degree, and really who I am, I would say I've turned my job title into self-proclaimed division geek. So I literally get to, as I was saying, get paid to talk about prime numbers all day, and I love it. I go from anywhere from pre-K kindergarten classes showing kids kind of different ways of counting, all the way to AP calculuses talking about different ways of taking derivatives and anything in between. So one day, in the morning, I was talking with young kids just on ways to count to 10. In the afternoon, we were talking about complex fractions. So I have an exciting, every day is different in my world.
Wow. Is it hard to kind of switch back and forth mentally when you're doing that kind of stuff?
Yeah, it is. But at the end of the day, you find out that every math student just has the same desires. They want to play, explore, and feel justified in their thinking. So no matter the grade. Okay.
And you seem like you are definitely in that, you're playing in that kind of playground where you're really excited about math. And so what is it that gets you excited? Because when I think of math, I confess, I don't get all that excited.
Yeah. I see. And that's what excites me the most is the more I talk to people who don't find math exciting, the more I come alive, is because I think that there's this untapped world that, I think growing up, I was born in 1982. So math to me was the late 80s, early 90s. And math was brought to me as almost an elitist subject. And I wouldn't say no fault of teachers, just I think that's what society has kind of turned mathematics into, that there's people with this innate ability at birth that's determined whether they can or cannot determine what a prime number is, right? And it's sad because, sorry about that. We hear parents say all the time that, I can't do math, and so probably nor can my kids. And as if this like prime blocking gene has been passed on from generation to generation,
right.
Which totally isn't true. But, we would never say that about reading. We would no parent would ever say, well, I can't read, so my child shouldn't read either. Yeah. But for some reason, mathematics feels like it's okay to say that.
Well, okay, I gotta work out some personal demons here with you though, because if you'll allow me that. I went to university for computing science, and I did pretty well in math all through high school. I did all the AP courses. I had some great teachers. Went to university. I bombed big time, and I switched out of computing science in the halfway through my second year. It's a lot more complex than just math sucks and I hate it and I'm gonna do something else. But I had other passions that I wanted to pursue. But at the same time, I remember once, and literally like just working an entire weekend, trying to get one assignment done, 4 questions. I got 2 of them done. I couldn't even get the rest of them done. I was spending like 10, 12 hours a day, literally just on like my computing science and the math and the logic. And I just remember talking to, a classmate and just saying something along the lines of like, God, boy, that was a pretty hard assignment. Hey. And he just looks at me. He's like, no. Right. So, So I kind of took a cue from the cosmos there that maybe this isn't for me. So, so how does that work in the context of, well, anyone can do math and we shouldn't say that we're not good at it? Cause I feel like I put some effort in and I didn't get back, the success that I so strongly desired.
Right. So what I actually do is I always change the narrative. I don't believe anyone's bad at math or anyone truly hates math. What I think people are bad or hate is how math is brought to them. And I think as we go up higher and higher levels, math becomes more and more abstract, right? Mm-hmm. And I think, so one of my jobs, one of my passions is how do we bring math literally into the hands of the learner? So we call that concretely. So that looks like in kindergarten, kids playing with blocks, making 10 frames. In higher grades, it looks like with fraction blocks. Right. And then I find that as you get up, even into high schools, that concreteness, and especially in university, is almost absent. In fact, it's not even existent. Mm-hmm. And we go right into this abstract way. And I think, I think math is a beautiful abstract idea. But of course, it never started abstractly to me. I got to play with it. I got to do messy things with it. And I think what we need to learn as educators is that we got to try our hardest and be creative into ensuring that continuum of starting with something in your hands concretely, mm-hmm. and then going into the abstract world, as opposed to just starting at the abstract world. Because I think we lose kids. And, and I think that's where we hear a lot of it. When am I ever going to use this? Why do I care? Right. Because I think we started with this abstract idea. And I think what they're really saying is, I have no connection to what we're learning. I don't care.
That's. Sorry,
go ahead.
No, I was just thinking, you're just sparking this thought in my mind. It's math is an applied science.
Yeah. Math is, math. I think of this. Math makes our brain the playground, as Francis Su said in his book, Mathematics for Human Flourishing. I think that we've turned a subject, and not even in a subject, I would say just an awesome experience, into this sometimes mundane, worksheety, do the same thing with different numbers over and over and over again. As opposed to, well, let's just stop for a minute, and instead of trying to do 20 problems today, let's try to do 2, but really deep. Mm-hmm. Mm-hmm. I think, and I was just recently in a grade 1 class, so talking to teachers, as opposed to asking, what's 8 plus 2, 7 plus 3, these kind of mundane questions, the kids came alive when I asked them, how many different ways can we add 3 numbers together and get 10? Show me all the ways that you can do that. And the conversations and the engagement went through the roof. It was just a simple change in that question.
Right. Well, it kind of turns it into a challenge.
Correct. And it almost has this mysterious thing to it, because math is truly math is not a memorizing subject. I never think it is. I think it's a pattern seeking one. And most problems can be solved by, if you think of it not as a set of rules to follow, but almost what's the pattern here that we're looking at, whether that be quadratics, whether that's adding fractions, or whether, again, that's just counting to 10.
Mm-hmm. Mm-hmm. Okay. And so you've got a long... Gosh, I'm sorry. It's the morning and I haven't had my coffee yet.
No worries. And it's Halloween.
Yeah. Oh, yeah. Don't even remind me. Oh, yeah. Okay. So you use a lot of technology to engage your learners. I mean, how do you approach that?
Yeah. So that's one of the sessions we're running at ERLC, is how to actually engage them with tech using Equatio, Desmos, and so on. And I think that's one way I found, is taking an abstract idea and literally allowing kids to play with it. So as we go into junior high and high school, right, we have the old age of computer, let's think of TI instruments, where you would graph 6 functions and it would take this archaic long time to see it. Yeah. Well, now we have the ability literally to graph one function and play with the slider and see instantly all the different possibilities, or all the infinite solutions you could get, right. And how it, affects the graphs. And now we can turn math into, not entirely inquiry modeled, but definitely we can start dabbling into that area. So as opposed to me having to tell kids this is what it does, I almost set the environment up for students to explore, and then ultimately discover on their own what each parameter may or may not do.
Cool. And you said you've got certain tools that you're using. I always record a little bit ahead of time, the intro. And so I tried my best to pronounce these names, like Equatio, Desmos, and Geogebra?
Geogebra. Yeah.
Geogebra.
They're all free programs. For Equatios, I believe it is cost for students, but from a teacher's point of view, it's free. The other two, Geogebra and Desmos, are the computing software that's free for teachers, simple to use, and you can create, and now this one I always mess up, GIFs or GIFs, however you want to pronounce it, but these, repetitive animations. Yeah. And just even something like the other day is, again, something very simple. We could show a number line and ask them to label all the numbers. Yeah. What I did is simply had a point animated across a number line and ask kids to scream out really loud when you think we're at 1 million. And it was really cool to just see, again, the different engagement there, that it's almost this mysterious thing, this blank number line, and arbitrarily a million can be wherever you want because I had no points on it. But it was really powerful, right? And then I talked about that. A million could be everywhere, anywhere. And what are the implications if we put million here or 1 million there or 1 million further down? And so it creates more of a conversation. And so there's a perfect example where one question might take a half an hour, as opposed to, I don't know your experience, but my experience in math was to see how many questions you can do in 60 seconds.
Yeah. I think that's actually literally what it was. It was a mad minute.
Yeah. And so unfortunately, I think we still have this, we have to change the paradigm in that math isn't about speed, and it's not about, the quantity of questions you can solve. And I was saying that in my master's, I learned something very valuable, that a question, you might look at it, actually put it away and say, I'm not going to finish this today. Come back to it maybe a week later, and you'll have entirely different insight as your subconscious kind of was percolating through the problem for you.
Yeah, that's absolutely true. I mean, that's true with really any problem, math or otherwise. It's good to kind of walk away and come back at it with fresh eyes. And a lot of times it's amazing how quick the solution presents itself.
Right. And so I like now let's like hypothesize this. How many students do you think K to 12 get that image of mathematics? That raise your hand is probably the most common mathematical problem solving strategy in a K to 12 math class.
Yeah. And that's, yeah, that's a little dicey. So, okay. Technology is a big part of what you're doing. I mean, how does that work with, teachers who maybe aren't in a one-to-one environment or, have trouble accessing the technology?
Oh, for sure. So the tools that I'm going to be talking about is, in fact, I'll probably be presenting them not as one-to-one. Originally is just some ideas that what can you as a teacher create? So how can you amp your lessons up? Absolutely, though, I think technology in the hands of the learners is even the most powerful thing. But of course, if we don't know how to use it, then it would, how are we going to teach kids how to use it? And so the first thing is that just even showing an animation on a projector and having a conversation about it can spark wonderful and deep conversations, as opposed to this kind of like, maybe a static picture where we just kind of look at things.
Right. What was your experience, as a student with math?
Oh, I got a very, I would say, very traditional math teachings, right? Where we'd sit in rows all the time. We would repeat questions and apply. Now, I'm probably I'm reminded constantly by my friends, I'm a different sort of person because I love numbers. Like, you have no idea. When I see a freshly sharpened pencil, I get excited. I'm like, today's going to be a good day.
Wow.
And so, but see, that paradigm worked for me. So nowhere to lie, Shane, when I started teaching, what did I do? But perpetuated the machine. I did exactly to my students what was done to me because it worked for me. But I found quickly that there wasn't probably more than 2 grade 9 students who actually were intrinsically motivated by the Pythagorean theorem.
Yeah. Kind of cut from the same cloth as you.
Exactly. So while I was engaging 2, I was turning off 28. And so very quickly in my career, at about 3 years in, I had to realize that, this isn't going to work. That I want to bring mystery. I want to bring play. I want to bring enchantment to math, because those are the things that I find intrinsically motivating about mathematics. Asking the question why as opposed to how. I think of, adding fractions together. I think we jump too quickly on how to add fractions as opposed to why, or when is it when is it easy to add fractions? When is it difficult to add fractions? And as opposed to just follow these 3 steps of algorithms and repeat. It's this very mundane algorithmic thinking.
Right. So it sounds to me like you're somewhere between sort of traditional math and I guess what they call new math.
Yeah. So I'll be honest. I hate when people use new math and the reason I say that is, 3 plus 3 still equals 6. And I know that this is the societal thing that, I see things on Facebook all the time about old math and new math, and I laugh. It's still math, right?
Yeah.
But yes, I agree. I would say I'm in the middle in that. I'm not as far as I don't believe if you just throw numbers at kids, they'll just learn osmosisly how to count. But on the other hand, I don't think it's interesting if we just always tell them how to count.
So what's the middle ground here for you then?
Yeah, so I think the middle is a mixture of what those 2 ways, those 2 ends I just described. So obviously still some direct teaching involved. There's some things that are going to need to be kind of more taught, but at the same time is always asking is what's the play angle? Meaning, how do I get kids to play with this idea? Right. And I mean play as in like the actual true play, where maybe it's self-choice. So kids have all different opportunities to play. It's like what we said earlier. If they don't like playing and they're like, I'm done, cool. Then walk away and let's start playing with something different. I look at how my 6-year-old plays at the playground. I want that feeling in math class, this kind of messy, dirty feeling. But of course, sometimes as the parent, I have to tell my daughter no, and this is what we're going to do. And I think that's kind of with teaching, right? That it's almost this guided play, I guess, is the word I would use if I had to come up with a word.
Yeah, no, that makes sense. I mean, it's like the difference between, like running your basketball drills and playing a game, right? You still got to run the drills.
Right.
You still got to.
Yeah.
Sorry, go ahead.
No. And I was exactly, and I love that. I love the analogy of sports, because I think that even at the end, right, the whole goal of a basketball coach is to get them to that final game and great success. But see, and there's an analogy that falls apart, because if you look at it in a math class, what happens at the final? Well, they're usually sitting in rows in silence in this
they're still throwing baskets.
But I have yet to see a coach sit silent on a bench on the final tournament game. I have yet to see a coach not engage with students on the fly and give them feedback. Right. And I even think that, like so in my high school classes, I successfully pushed the envelope as far as I removed a final exam. So at the end of my even AP calculus classes, even diploma classes, no final. I turned it into this kind of group presentation. Almost, I actually would call it a dissertation.
Okay.
So students had to convince me in an hour talking to me that they've mastered the top 10 ideas that we learned that year. And Shane, I can attest that I learned more about a kid's understanding in 60 minutes of conversation than I ever did in a 4-hour test.
Yeah. Wow.
And I think, and what was even more interesting is I had kids coming to my final, if you will, this presentation, excited, proud, because they were going to show off things they had created, as opposed to, the traditional assessment where really they're working on my product. They're working on something I created. There's no enjoyment there.
Yeah. So this is actually putting math in their hands.
Yeah. And you should see, I had kids doing Three Little Pigs and talking to me about the story of the Three Little Pigs and the analogies they can make to their AP Calc learning. Yeah, it was very, very powerful stuff.
Wow. I mean, how much of that can you remember? Because I'm actually really intrigued. Like, how do you get AP Calculus and Three Little Pigs working together?
Yeah. So the first story was, so one of the things they had to talk about was change in volume. So the little sadistic, but they turned it into, what if the wolf, instead of blowing a house down, actually sealed it and filled it with water? So, and how would, right, at what point in time would the pig's height be drowning? And then at what rate is that water going up at? Yeah. So this very sick sadistic way, but it was interesting. And so here are kids coming in, no jokes, in pajamas, wearing pajamas, putting me in a Snuggie. So I'm sitting there in this little Snuggie, and they're reading a bedtime story to me about AP Calc. And what was even more, the most powerful thing I experienced was kids were showing this off to their friends and family before I had a chance to look at it. And the reason I say it is bonkers, because traditionally, when does something go on the fridge? After the teacher validates it. Yeah. And here is kids, they didn't need validation. They had self-validation. They knew what they created was amazing and intriguing. Yeah, it was extremely powerful.
That is just fascinating. I mean, so it sounds like you've got this real thrust in your own teaching on sort of getting kids to understand that math is something that helps them to describe their own world. It's not just numbers for the sake of numbers.
No. And again, like I said, I truly believe in my heart that every person, every single one, can master math at the highest levels. I say to teachers, K to 12 all the time, I have a master's, but I believe everyone in this room can get one too. And usually 3 people get hives, just even thinking about it. And it's funny because there's definitely some people out there with a fixed mindset around mathematics that either they get it or they don't. And I think as we know about anything about learning is it's a continuum. And I think maybe we've brought we're trying to sell an amazing product, but in the worst form sometimes. And that form sometimes is mundane, repetitive worksheets. And of course, no one's going to get excited about that.
No, absolutely not. Well, it's funny because in the back of my mind, every time you're talking about, making math practical and hands-on, there's literally like one math class that I remember specifically from high school. Because it was a day, I guess we were doing geometry or something, and our teacher gave us like a protractor, like one of those really big ones, like, it's like 30 centimeters at the base. He gave us a protractor, a piece of chalk, and a string. And he said, okay, go measure the height of the building.
Oh, that's awesome.
And we're like, wait, what? He's like, go measure the height of the building. And so we had, we started like, what are we supposed to do with this stuff? And, eventually figured out that we can, measure angles and distances of the building. And so, we were able to estimate the height of the building within, I don't know, like a meter, I think, or something like that. Pretty close.
Yeah.
And it was, but I mean, I remember that was 1997.
Right.
And yet that was just one of those things because it was hands-on and it was like, oh, hey, math can do stuff.
Exactly. Yeah. See, and there's a perfect example that if we start there, now the hook is in, the rest comes easier.
Mm-hmm.
Right. But if we leave those fun projects to the end, we're usually lost the students along the journey because they realize, I'm not going to walk the 100 miles to get to the oasis.
Yeah. Yeah. It's going back to the basketball analogy where if basketball, all it was just standing and shooting free throws all the time, not that many people would be into it.
No, exactly. Yes. And only once that you show me mastery, can you play a game? Oh, that would be silly. Right. And here exactly. And I love that analogy because, you see kids all the time playing basketball who probably aren't good at it, but have bigger smiles than I've ever seen because they're having fun doing it. And I think of what if math was like that? What if people smiled when they got wrong answers? And and let that sink in. Right. Because again, like that's another paradigm shift we got to bring to the math class, that being wrong isn't bad. In fact, in my master's, in my undergrad, in my own schooling, I can tell you this, I have been wrong more times than I've ever been right. And that's something that I've acknowledged along the years, that to get right answers, sometimes it makes you have to go wrong and realize, oh, that didn't work. Let's try something else.
Absolutely.
But transform into a traditional math class where it's almost no one's allowed to do anything unless you absolutely for certain know what you're doing.
Right. It's like there's like this shining, whatever, at the top of the room that's like, this is the right answer. This is what we all aspire to.
Right. And I think of, let's do another, playing with technology. Look at kids playing with an iPad for the first time. It's not that they're good at iPads. They just don't care if what they do is wrong.
Yeah.
They're going to push buttons, right? And George Curl said this, and I love this line. Kids aren't better at technology than adults, right? They just, they're more willing to try something and be wrong about it.
Oh, yeah.
And I love that line. And let's take that to numbers, to operations, to factoring, right? Take a chance, be wrong, and let's learn from it.
So,
Sorry, go ahead.
No.
No, I was just saying, and I was just going to say in a very traditional math class too, answers are usually in the form of punitive or deduction of marks.
Yeah.
So if the commodity of your math class is marks, and when kids make mistakes, we deduct them, well, then it makes perfect sense why kids would be terrified of trying new things.
Yes, absolutely. I mean, and I teach computers, and believe me, I have kids who are terrified of trying new things. So,
right. Oh, if you, as a computer science guy, you know this, right? When you do coding, I don't think in any coding I've ever coded, it ever worked the first time, right?
Oh, no.
Like you have that dream where you're like, oh my gosh, I've looked at these lines, but every time you hit compile, there's always an error,
Yep. Oh yeah. Yeah.
And you learn quickly that is part of computer science.
Mm-hmm.
That's a normal thing, right? And what do? You go to the line that has the error and fix it.
Yep.
And I think of the same thing we need to take to learning of mathematics, the exact same thing.
So how do you do that? How do you actually kind of teach your kids that failure is okay? Because I mean, like I said, I pound on that drum pretty hard in my class that you're allowed to fail. It's okay. And you can see the gears just grinding. Like what? That doesn't.
Yeah. There's a coin. I'm gonna coin a phrase that a good colleague of mine, Jody Smith, says all the time, that we need to normalize mistakes.
Mm-hmm.
And I think that. So how do you do that? You normalize mistakes. Now the question is, how do you normalize mistakes? I guess is first off is by always trying to make mistakes yourself. So I say to teachers, and my challenge is all of them, is how often do you yourself try a math problem you do not know what to do in front of the kids?
Mm-hmm.
Right? How often do kids see you struggle? Because I think it's detrimental to students if the math teacher is always the answer, the back of the book, if you will, the person who just knows things. We actually have to model struggle. We have to model being wrong. And what do we do in that? And when students start seeing that from the teacher, from the master of the room, I think this will become more normalized. That, I'm just acting like, my teacher when I do these things.
Yeah. Yeah, absolutely. I completely agree. I mean, I don't teach math, but I've, I don't know, probably a couple of years ago, I kind of came to that realization. It's like, I need to start doing what I'm asking my kids to do and failing. So, I mean, like I teach drama and, whenever we do a new game and even occasionally when it's an old game, I'll still get up and I'll be in a scene, an improv scene. And, there's times where I'm just like, wow, that was terrible. Like I just fell on my face. But, I'll say that to my kids, hey, guess what? That was awful, because here's what I should have done, but I did this instead. And so, and I think that, in math and any subject area, seeing that is, it's an encouragement, I think, to a lot of kids.
For sure. And what you just said there is I think is something more and more we also need to embrace. That actually what you just described is getting in and doing it ourselves. Mm-hmm. I know that I find huge enjoyment solving math problems. Like, I love when I go to a grade 2 math class and there's a problem that I don't know what to do. Yeah. I love it. I get excited, right? I'm like, how can this? All we're doing is adding, and I don't know what to do, because maybe it's a tricky problem, maybe it's a puzzle. Mm-hmm. And I often encourage now all my teachers is, how often do you actually do math? We're not talking about math pedagogy. We're not talking about engagement. We're talking about the actual field of mathematics. Because I can attest to this. The moment you start enjoying it, the math speaks for itself. There is no why do I need to do this? I was working with a grade 5 class the other day, and we called them funky numbers. Other people would call them primes. Okay. But all I was doing was giving them blocks and saying, what are numbers that are nice to arrange in nice arrays and numbers that aren't? And I had kids telling me, like, 7 is a funky number. You can't put 7 in a nice little rectangle. Yeah. And kids were getting frustrated. And then they found, oh my gosh, 13's another one, 11. And kids started erupting with this joy about these funky numbers. Yeah. And then afterwards we said, hey, we call those prime numbers. And that was it. As opposed to, here's a prime number, here's a composite. Now here's a worksheet, circle the prime, circle the composite. There's no mystery there. There's no enchantment. There's no joy. And so physically getting kids to take these abstract ideas and play with them, it's so awesome to see the engagement and true joy come out of these ideas.
Absolutely. Absolutely. It almost, I don't say it masks it, but you kind of forget that they're doing math because it's just they're playing.
Yeah. It's funny you say that. I'll start usually with my friends. I got a problem for you. And their first question is this math? Like, are you going to trick me into doing math? And I laugh. Like, I say, oh my gosh, every problem is math. Like, if you want to define what math is a problem solving subject, we'll say almost everything you look at is a math problem then. Mm-hmm. Like, you should be terrified of thinking about anything then.
Oh man, you just totally turned my day on its head. Thanks a lot. I'm going to think about math all day long.
Yeah, but that's a good thing, right? Like, you should be joyful to realize that we use math every day, all day, in probably ways that you don't even think about. Oh, we take it for granted.
Sure. Yeah. Okay, so let's bring this back around, because you're going to be sharing a lot of probably what we already talked about, but let's just see if we can kind of like put it in a nutshell. So on December 9th, what can people expect to be picking up at your session?
Yeah, so how to make abstract ideas come alive with technology. So I'm going to show people just quickly, even and very quickly, obviously the session will go long, but how you can simply just take an idea, animate it, make it into a GIF, if you will, and how a simple animation can probably spark a very heated math argument or a very deep math conversation, watching. And so we're going to do that. We're also going to show ideas of how you can use some of these activities in the hands of kids. So whether it is one-to-one, that's great. If you don't have one-to-one, then how you can maybe use maybe one Chromebook and create a centers. We call it a math workshop, but how you can have kids literally playing with abstract ideas, but in their hands.
Fantastic. That sounds great. And actually, you've got a January 27th session as well, differentiating math assessment in the grade 7 to 12 math class.
Yeah, so that one I'm just as excited for. So what we're going to do there is, and so actually I'll start with a question. And the question is, why is it that we talk about differentiated instruction, yet we never talk about differentiated assessment? If kids are going to learn different ways at different times at different speeds, why do we assess them all the same way? And so that's going to be the question I'm going to answer in that session. So what I went to as a model, and I'm going to share my story in the session, but quickly, is I went to a model where I actually differentiated assessment in my class, meaning kids wrote different assessments on different days and it looked differently. As I realized that some kids learn outcomes faster, they would be assessed. When kids learned it slower, that's cool. Take your time and we'll assess you later. And so how do we take the paradigm from what probably most junior high and high school teachers are doing, which is here's a unit, we'll do a bunch of questions, and at the end we all test on the same day. When in reality, that's too late for some and too early for others. Right. And so how do you kind of shift that model into a way that still fits in the confines of obviously the Alberta curriculum, that still fits in the confines of a limited timeline, but we'll talk about how, not everything in the curriculum is equal. there are some outcomes that are heavier than others. And what if we focused on those deeper than the other ones? What would happen? So yeah, that's kind of those two sessions in a nutshell.
Fantastic. All right. Well, Dave, thank you so much for your time today. This is it's been a great chat.
Yeah, you're welcome, Shane. Yeah, that's awesome. Thanks for having me. It was a good time.
Absolutely. All right. All right, thanks again to Dave for joining us today and sharing all his knowledge. If you want to learn more, he's got 2 upcoming dates. The first is December 9th. That's Engaging Math Learners with Technology, Equatio, Desmos, Geogebra, and more. And then on January 27th, he's doing a session called Differentiating Math Assessment in the Grade 7 to 12 Math Classroom. Both sessions will be at the ERLC office, and you can register at www.erlc.ca. All right, that's it for this time out. So we'll see you next time on the ERLC show.